Assalamualaikum warahmatullahi wabarakatuh. Today we will look into chapter 6 brake and clutch under the subtopic of long shoe brake. One of the characteristics of long shoe drum brake compared to the short shoe drum brake is the contact angle between the shoe and the drum is more than 45 degrees. And in long shoe drum brake, we assume that the pressure, which is the pressure which occurs between the shoe and the drum, is not uniform, where varies from any distance, which is from this distance until to this distance. We can find the value of moment of normal force, which is Mn. So Mn is equal to Wr Cp divided by 4 sine theta m, then times by 2 theta contact angle minus sine 2 theta 2 plus sine 2 theta 1. W is the width of the shoe, long shoe, and then R is the radius of drum, and then C is the distance between fiber point of the long shoe drum brake to the center of the drum. And then Pmax is the maximum pressure which occurs between the long shoe and drum. Then this is theta for contact angle between the long shoe and the drum, and then we have theta 2, theta 1. So theta 2 and theta 1 I will show you on the figure. Where is the location of theta 2 and theta 1? But for sine theta m, so sine theta m is based on the value of theta 2. So if theta 2 is more than 90 degree, the value of sine theta m will take as a 1. If the value of theta 2 is less than or same with 90 degree, we will take sine theta m as equal to theta 2. In this figure, we can see that the value of R here. So R is the radius of the drum, and then we can see the value of C. So C is the value or distance from fiber point A to the center of drum, and then we have angle of contact here. So this theta is our angle of contact. So angle of contact is the angle between the long shoe and the drum start to contact until the end of the contact at here. Next, we have the value of theta 1. So here is our value of theta 1. So how we measure the value of angle theta 1? So the value of angle of theta 1 we measure from fiber point A to the center of drum until the very beginning of contact between the long shoe and the drum here. So this is the angle of angle for theta 1. And then we have angle theta 2. So for theta 2, we measure it from fiber point A until to the center of drum. So this point, this line AO, until to the point where the last contact been made from long shoe and the drum here. So this is the line. So theta 2, we measure it from line AO until to the last point of contact here. So if theta 2 is more than 90, we will take the value of sine theta m equal to 1. But if theta 2 is less or same with 90 degree, we will take the value of sine theta m is equal to theta 2. Next, due to the friction occurs between the long shoe and the drum, so there is a value for moment of friction force, MF. So this is the equation of moment of friction force. We just use it, and you can get this equation from the booklet. So moment of friction force, MF, is equal to F WR P max. So F is the coefficient of friction between the long shoe and the drum, and then W is the width of the long shoe, R is the radius of drum, P max is the maximum pressure which is occurs between the long shoe and the drum, and then we have sine theta m. So sine theta m is referred to theta 2. So if theta 2 is more than 90 degree, we assume sin theta is equal to 1. But if theta 2 is less than 90 degree or same with 90 degree, we assume sin theta m as a theta 2. And then we have C. So C from the figure is the distance between the fiber point to the center of drum, and then we have theta 2. So from the previous figure, we know that theta 2 is the angle between fiber point to the center of drum, line AO, until to the line of where the last point of contact between long shoe and the drum. And then we have theta 1. So theta 1 is the angle between fiber point A until the radius center of line A to the center of the drum, and we measure into the very beginning of point of contact of long shoe and the drum. So that is for our theta 1. And then for R, so R is the radius of drum, and then theta 2 and theta 1. So for long shoe drum brake, we can find the value of actuating force Fa by using this formula, which is 1 over A Mn and Mf. So sorry for that mistake. So the equation should be Fa 1 over A Mn minus or plus Mf. So minus or plus is depending on the types of the long shoe drum brake. So the upper sign for our formula of actuating force, which is Fa 1 over A Mn minus plus Mf. So minus is for the self-energizing brake, and then plus if the long shoe drum brake is in self-de-energizing brake. So self-locking occurs when the value of Mf is more than the value of m. Then you can find the value of torque capacity for Longshu drum brake by using this formula, which is torque T is the value for torque capacity, F is for the coefficient of friction between the Longshu and the drum, and then W is for the width of the Longshu, R is the radius of drum square, and then Pmax is the maximum pressure. And you have cos theta 1, so theta 1 is the angle between fiber point A to the center of drum until to the very first of contact point Longshu and drum. And then we have theta 2 here, so minus cos theta 2. So theta 2 is the angle between fiber point A to the center of drum until to the line where the last point of contact occurs. And then we have sine theta m. So sine theta m is with respect to the theta 2 value. So if theta 2 is more than 90 degrees, sine theta m we assume as 1. But if the value of theta 2 is less or same with 90 degree, so we assume theta sine theta m as a theta 2.